formulas are. They're going to be in this order. I just copy and pasted. That's all I did. So also, if you want the other one, you might want to write in the one that you like. A sub n equals a sub 0 plus dn. I don't know if you like that one. I like that one personally. If you don't, leave it off your paper, okay? So tomorrow, I'm going to hand out the test. I'll tell you this one. If you want to write it down at the top, you can. If it bothers you and you don't use it, then don't write it down. I'll give you that option. Okay, so if you look, these right here are arithmetic. This is arithmetic recursive right here. And this is arithmetic explicit. Both of those two are, okay? And this is arithmetic formulas. Arithmetic, it has a common difference, yeah. Probably not for you, you're pretty quick, but it might take someone the whole period. It's just front and back, it's not, it's not too long. It's like this. All right, over here, these are going to be our geometric formulas. I'm really making a mess of this, huh? Geometric, and this is recursive here, and this is explicit here. Okay? Over here, these are our sum formulas, and there are 3 of them. This one right here is the sum for arithmetic, finite arithmetic. Okay? And these over here are for geometric. You can tell which one's finite and which one's infinite, right? Do you see the infinity symbol right there? That's the infinite one. This is the finite one. N terms means finite. Okay, so that's all of them at the top. They're all in order of how you learn them. I did not mix them up to confuse you. They're going to be in that order, okay? So let's get started. Here we go. So number 1, it says, given the sequence 2, 6, 10, 14, blah, 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 find a recursive formula. So this brings us back to that first quiz. So first of all, you need to decide what's happening here. What is happening between terms here? What are we doing? Adding 4. Perfect. So for this one, we are adding 4 each time. And so our common difference, I can't write on this very well, is positive 4. So now let's write a recursive formula. So we go to our recursive arithmetic formula, which is the first one up there. So we're going to go a sub 1 is 2, and a sub n is a sub n minus 1 plus 4. Keep everything exactly the same as it is. All you're doing for this formula is filling in this number and that number. The rest is the same. Yeah?
Do you want us to write the d equals whatever? Or can we get more off of that?
No, you don't have to. Nope, that was just me showing you what it was. This would be the answer, and that's all you need to write. All right, now let's do an explicit formula for this. So go to arithmetic and go to the arithmetic explicit formula, whichever one you like better, okay? I personally like to do a sub 0 plus dn. What would a sub 0 be if I was to go back 4? It would be negative 2 plus 4n. So that's my explicit. If you don't like that, you can write the other one, and it'll get you there too.
For the other one, it would be
an equals 2 plus 4 times n minus 1. Sure, that's fine. So I'll put a big fat or there. Either one, whichever one you like. Let's take a poll. How many of you guys do like the a sub 0 one better? You guys are my favorites. And then how many of you guys like the other one better? Second favorites. Your face. I'm kidding. Oh, that's sad. Okay, here we go. Now let's find a sub 15. So a sub 15, that means I need to find the 15th term. Well, this only lists the first 4 and then this other one at the end. So what would be the 15th term in this? How am I going to find that? Plug it in for n. Yes, n equals 15. I'm going to plug it into one of my explicit formulas here. And it doesn't matter whichever one you plug it into, you should get the same answer. Negative 2 plus 4 times 15, 58. Very good. Okay, now take a look at the last one. The last one is asking for the sum of this up here. 2 plus 6 plus 10 plus ... to 118. okay, to 118.
It doesn't matter that you skipped 14.
It doesn't, not really. Yeah. All right, so what we're going to do is we need to find the sum of this. In order to find the sum, we first need to do which sum formula am I going to use. So I go up here, and I'm going to use this sum formula, arithmetic finite, okay? So I go sum equals n. I don't know what n is, but I do know it's not 5 because there's dot, dot, dot. There's a bunch of numbers in between. It goes 2, 6, 10, 14, and then there's some numbers that are missing all the way to 118. Here's what you want to do. It's the number divided by 2, the number of terms over 2, first number plus the last number, and now I have to find out how many numbers there are. Do you remember how to do this? You're going to take 118 and you're going to plug it in for a sub n into your explicit formula. So I'm going to go 118 is equal to negative 2 plus 4n. And I'm going to solve that for n. I'm going to find out what number term 118 is. Because 118 in this formula up here is a sub n. So if I plug it into either one of these, it doesn't matter. You solve. What'd you get? 30? All right, 30. Okay, let's go ahead and what? Oh, you add 2 over. So you get 120 and then divide by 4, so 30. So now let's go ahead and find the sum of it. I'm running out of room. So we're going to go 30 divided by 2 times 120. 1800. Yep, the year I was born. Good. I've aged really well. All right, there it is. Nope. Yeah, I don't even think the wheel was invented. Okay, so here we go. You feel pretty good? That's just the first problem. That does a lot, though. That went through the whole chapter, really. Had you do recursive, explicit, and find the sum. All for arithmetic. All right, let's do it again. But this time, we have a different kind of sequence here. What's our sequence this time? Recursive, geometric, yes. And what are we multiplying by each time? 3. Okay, so the common ratio, or the multiplying number, is 3. So let's write a recursive formula for this. So recursive is you start by telling me where to start. In this case, you're starting at 2. And then you tell me to find a sub n. You take a sub n minus 1, which is the previous term. And what are you doing to the previous term to get the next term? Times 3. Whatever times symbol you like. A little dot, a multiply, parentheses. There's a whole bunch. I was helping my child with his homework and I wrote a dot. It was 1/4 dot 3. He was multiplying and he's like, what's that dot? I'm like, oh. And I wrote a times. He's in 5th grade. Yeah.
So when we have to find like for C, you could use any formula to find the time.
There's only one. You want to use the explicit formula.
I mean like just for those 2 formulas.
Well, there's only one explicit formula for geometric. Yeah. All right, so let's do our explicit formula. Here we go. Explicit formula is a sub n equals a sub 1, which is 2, times 3 to the n minus 1. Okay? Do you see it? It's right at the top. Okay. And now to find the 8th term, a sub 8 equals 2 times 3 to the 7th. This is 8 minus 1. Yeah? It's pretty big, huh? 4374. 4374. That's the 8th term. Okay, now finding the sum of the geometric for 8 terms, we're going to use this formula right here. This sum for geometric for finite numbers. 8 is a finite number. 8's not infinity. It's like a sideways infinity, right? Okay, so here we go. The sum of 8 numbers is to do a sub 1 times 1 minus r, 1 minus 3 to the 8th power, divide by 1 minus 3. Now I put parentheses like that. I know that the formula at the top has like a big parenthesis, but you want parentheses around the top and the bottom. Now try it. If you haven't been doing these all along, try this in your calculator right now and see if you get the same answer that I do. If not, then you're inputting it into your calculator wrong, and we need to fix that before tomorrow. I got 6560. Anybody else? Yeah, you taking my word for it? You want to practice it? You should practice.
Yeah.
Yeah, good. Okay, nice. Good job. All right, so that's the first two. Now let's go on. Number 3 and 4, bless you. 3 and 4 are going to be 65, 60, yeah. 3 and 4 are going to be the ones where you have to know a formula here. Or you have to like generate the sequence. So it says write the first 4 terms. So what I like to do is this. I like to go 1, 2, 3, 4. 4 terms, okay? Those are commas in between. And it says the first term is -5. So let's go ahead and put the first term in. And I really just have to find 3 more. And what does this common difference tell me to do? Perfect. Add 7. We're going to add 7 each time to get the rest of them. You don't need to make an explicit formula. Okay, you just need to add 7. So then we get what? 2, 9, 16. Oh yeah, look outside. That's a really cool van. Blinded you. Okay, here we go. Number 4. It lights it up. Number 4. It's real lit in here. All right, write the first 4 terms of the geometric sequence where a sub 1 is 20. Okay, let's do it again. This time I have 20, and then I need to find the next 3 because I'm doing 4 total, 4 of them total. Okay?
40.
Yes. What kind of 40? Negative 40.
80.
Positive 80. Good. Negative 160. Very good. Okay, so it's telling you to multiply by -2 each time. You just multiply by -2. All right, 5 and 6 were the ones I was thinking of earlier. These are the ones where you need to come up with a formula. Okay, you need to know the formula to find these answers. So arithmetic mean means the average between those two. So we're going to take 31 and 55, add those up, and divide by 2. What is it? 86, 43? 43. So the arithmetic mean, the number between them, is 43.
Is that it?
Yeah. I know, get that one right.
And the other one, you're square multiplying
Square root, The other one, to find the geometric mean, you would multiply them together. Take the square root. Yes, square root. So those are formulas you have to kind of know. I don't give those to you. What was it, 60? 60. There you go. All right, we're doing great. We're almost done with the front page. Okay, number 7. Number 7, it says write the first 4 terms of the sequence. Okay, these are different from one another. A is recursive or explicit? It's explicit, and B is recursive. Okay, so first 4 terms. 1, 2, 3, 4. Now to get the first term in this sequence, what do I need to do? It didn't give me the first term. How do I find it? You plug in n equals 1. Okay? You plug in n equals 1 and you get, you can do it on your calculator if you need to, you get 3 times -2, -6. How do I get the next one? Am I going to use the one before it? No, it's explicitly defined. Then I plug in n equals 2. And I get, what is that? -4. If you want to use your calculator, that's fine. N equals 3. Ooh, I know that one. Do you? 0. When I plug in 3, I'll get 0 times, who cares? And then n equals 4. You get 6. Is that right? 6. There we go. Okay? So you just plug in n equals 1, n equals 2, 3, and 4. Done. All right, part B is done a little bit differently. This is a recursive formula. And so it's going to get the first 4 terms, you're going to use what they tell you to start with, and you're going to use that to get the next one. It's like you're generating the next few terms. So the first term they tell me is -4. Now to find the next one, do you see this? This bothers some people. This right here, this a sub n minus 1, that just means the term before it. So to get the second term, I'm going to go 3 times -4 plus 2. that a sub m, see it's 3a sub n minus 1 plus 2. This right here gets replaced with the term in front of it, which is negative 4. So I get negative 12 plus 2 is negative 10. Now I'm going to do it again. This time that a sub n minus 1 is changing to negative 10 now. So I'm going to do 3 times negative 10 plus 2. And I get what? Negative 28? Then I'm going to do it again. And I'm going to go 3 times negative 28 plus 2. I kind of need my calculator for this. You got it already? Negative 82? Good. Negative 82. And those are the first 4 terms. 1, 2, 3, 4. If I do, it's in the top. So do you see this right here? 3a sub n minus 1 plus 2. This right here stands for the term before the term we want. So if I want the second term, I'm going to take the term before it and plug it into there. If I want this term here, I'm going to take the term before it and plug it into there.
How does that work?
3 times negative 10 plus 2.
Yeah, but how does it
Okay, it's not n minus 1, it's a sub n minus 1. So if you have a sub n, okay, if you have the 9th term, let's do a sub 9. What's the term right before the 9th term? The 8th term. What's the term right before the nth term? The a sub n minus 1 term. So this isn't n minus 1, it's the term before n. Cool, good. That's a hard concept. It is. It's weird, all the subscripts and stuff. But you're not plugging anything in for n here. You got to just think of this as the term before it. Okay? All right, let's go to the next page. Here we go. All right, now we're going to find some sums. Sum of sums. Find the sum of the series 4 plus 7 plus 10 plus 13 plus 64. It's just like the one on the front page. Okay? These are tough. That's why I put 2 of them on there so that we can practice them twice. So let's go ahead and first figure out which sum formula I'm going to use. And by the way, I do put all the formulas on the back side so you don't have to keep flipping over. They're at the top of both pages, okay? And on your exam, when you get to this, on the multiple choice section, they're all at the top of that page too, so that they're right there for you. All right, so find the sum of the series. So which sum should I use? Well, what kind of a series is this? What's it doing each time? It's adding 3. It's adding 3 to get to the next term. So this is an arithmetic sum series. So I'm going to use s equals n over 2 times the first term plus the last term. Well, I don't know how many numbers there are. But I do know that the first number is 4 and the last number is 64. Okay? So how do we find out how many numbers there are? So n is my question mark, a sub 1 is 4, and a sub n is 64. Well, let's go ahead and make an explicit formula. It's always explicit, okay? Now, if you like that one or if you like a sub n equals a sub 0 plus dn, it's up to you. Okay? So I would do this a sub 0 plus dn, and so the term before that would be 1. So a sub n equals 1 plus 3n. Okay, 1 plus 3n. And so now I'm going to take 64 and I'm going to plug it in for a sub n. So 64 equals 1 plus 3n, and we're going to solve for n. So subtract 1 to the other side. 63 equals 3n, so n is 21. So there are 21 numbers here. From 4 plus 7 plus 10 plus 13 plus 16 plus 19 all the way to 64, there are 21 of them. You can't see that. I didn't write all 21 out. That's no fun. All right, so then once you find that, you go to your calculator. 7 what? Ooh, okay. Times 68. I got 714, yeah. 714. There you go. Okay, there's a lot going on in that problem though, because they didn't give you all the information. They gave you 2 out of the 3 parts of that formula that you need. All right, let's look at the next one. A sub 1 is 5, D is 3, and n is 12, find the sum. Once again, they're not giving us all the information. We have to find some pieces. So this is a common difference, which means we're going to use the sum formula for arithmetic. We know that there are 12 numbers. Divide it by 2. We know that the first number is 5, and we got to find the last number. By the way, if this is all you can do and you forget how to do the rest of it, at least write that down on your test so I know that you know some of it, okay? Now, in order to find an arithmetic formula, let's put it into an arithmetic equation. Now, I've been using that a sub 0, 1 a lot. Let me use the a sub 1 now. So I have a sub n equals a sub 1 is 5 plus 3 times n minus 1. Now I need to find the 12th term because that's the last term that I need to find. N equals 12. I'm adding up 12 numbers. So how do I find the 12th term? Plug 12 in. I want to find the 12th term. I'm going to go 5 plus 3 times 11. Okay? What is that? 38? 33 plus 5, 38. All right, now go ahead, put it all in. Now I got it all. 6 times 5 plus 38, 258. There you go. Okay. Alrighty, now we get into sigma. Do you like sigma? No? All right, fair enough. All right, here we go. We're going to be given, and we're told, that is really nice, by the way, you're welcome, that this is arithmetic, okay? So we are going to go through and we're going to find all of these things, and then we're going to find the sum of it, okay? So how many terms are there? Can you tell by looking at it? We're adding up numbers from n equals 1 to n equals 40, so there are going to be 40 numbers, 40 terms. What's the first term? Don't tell me 1. The first term is by plugging in 1, okay? So what do you get? 4. Perfect. What's the last term?
40.
Nope.
No.
40, you need to plug 40 in, okay? So first term is when n equals 1. The last term is when n equals 40. Plug it in. 199. Perfect. Okay, now do not write all 40 numbers. Do not add up all 40 numbers. Use the sum formula. You have all the things you need to know. Plug it into your sum formula. Sum formula is the number of terms over 2 times the first term plus the last term. Okay, it's kind of nice. I like this problem. I think I give you one just like this because it kind of walks you through it in a way. 40, 60. It makes you have to find these things first, and then you have all your information. You just plug it in the formula. All right, number 11. How are we doing on time? Pretty good? All right, write the first 3 terms of the infinite geometric series. It tells me that the first term is 20, and r is 0.2. So that means that I'm going to multiply that by 0.2. So you can go to your calculator if you need to. Go 20 times 0.2 is 4. And now do 4 times 0.2. Go to your calculator, hit answer times 0.2. And now you're at 0.8. And you can see that these numbers are getting smaller and smaller and smaller all the way to infinity. So now let's find the sum. Do you see the sum formula? There's only one that goes with this. It's the sum of infinity. Where is it at? Oh, it got left off. That's why you flipped over, huh? You're like, what? This should have a little infinity symbol right here. I'll make sure it does on your test, okay? For sure. Sorry about that. Where'd it go? Is it on the ground? Are they all over the place? Where are they? All right, so the sum is equal to, and this is a really easy formula. Do you like this formula? I love it. It's one of my favorite formulas of all of mathematics. It really is. The sum of infinite numbers is to take the first number and divide it by 1 minus r. Beautiful. And what do you get? 45? 20 divided by 25. My age. Nice. Okay. When I first started teaching. Actually, I was 24. 1800, yep. Okay, here we go. Number 12. Do you see these? You're not going to use a formula for these. Nope. You don't want to use, oh, which formula is this? Is this arithmetic, geometric? You don't need to. Okay? What you're going to do is you're going to write out the numbers and you're going to add them up. There's only a few from 6 to 8. So let's go ahead and you have your calculator. We're going to plug in n equals 6 is the first n that I plug in. So I go -5 times 3 to the 6th power. And I get negative 3,645 plus -5 times 3 to the 7th power. Ew. Negative 10,935 plus. You see how I'm getting these, right? I'm just, oh, no? Let me do this last one and I'll tell you. Times 3 to the 8th power, and you get negative 32,805. Okay, here's how I got them. See this formula right here? This is an explicit formula. I plugged in n equals 6, and I got negative 3,645. Then I plugged in n equals 7. And then I plugged in n equals 8, and I stopped. Because this sigma told me to start at n equals 6 and to stop at n equals 8. And then I take those numbers and I add them all up. What happened? Did it get super warm in here? You're cold? I don't know if you got, I got negative 47,385. Okay, it's just 3 numbers that you have to add up. Yeah. Okay, you try this one. You try that one all by yourself. I'm going to plug in 7, and I get 51. Then I plug in 8, 66. And then I plug in 9, 83. And then I plug in 10, 102. You get each number, there's only 4, that's not a lot. And then you add them all up. I'm going to use my calculator because, you know. 302, who got that? Anybody get 302? Good. A lot of them did. Okay. Review session, 7:40 a.m. It's a $5 cover charge. Yeah?
How do you know which numbers you like, what to plug in?
It tells you. See this n equals 7? That tells you to plug in 7, and then 8, and then 9, and then stop at 10. There's your start, and there's your stop. Isn't that so cool? Don't you love sigma? Okay, number 13. Find the sum of the first 300 numbers. All right, how many numbers are you adding up? 300. What's the first number if you're going to add up the sum of the first 300 numbers? 1. What's the last number? 300. All right, beep, boop, beep, boop, get your answer. Okay, let's move on. 14. Ooh, good one. Yes, we have to do this one.
Can you go back really quick?
Yeah, you just plug all the stuff in. Careful, if you're going evens, 2, 4, 6, 8, what would be the 300th number of an even? 600. All right, 14. Write the arithmetic series using summation notation. All right, give yourself the best Greek letter you've ever seen, which is sigma. Go ahead, try and draw that. I dare you. And we're going to write this as sigma notation using for the first 15 terms. Okay? So, the first 15 terms, we're going to go n equals 1 to 15. They even tell you that. That's really nice of them. And now we're going to write an explicit formula. It's always explicit. So, what's happening here? What's going on? What kind of a formula is this? Yes, it's arithmetic. It's adding 5. So, if you like the one where it's a sub 1 plus 5 times n minus 1, leave it just like that. You could put like big brackets around it just so it's all together. Or, I'm going to write a big fat or right here. We're going to go n equals 1 to 15. A sub 0, this would be 2 plus 5n. Either way, okay? Whichever one you like. It didn't ask you to find the sum, just asked you to write it in summation notation. Summation notation, this right here means sigma, okay? Sigma. Do we have time? Maybe. Let's try it. 15. A 60-row theater has one aisle. Both sections have 20 chairs in the first row and 2 more in each succeeding row. So 20 plus 22 plus 24 plus ... for 60 rows. Okay, there's a center aisle. That means we're going to just get our answer and multiply it by 2 because that's just one of the sections. Do you know what I mean? Can you picture that? Like, here's the 20 seats, and then there's 2 more and 2 more, and then there's a center aisle here. So it's happening twice, but we're going to, you know, do it just times 2 at the end. Okay, so we're going to add this up. Now, this is arithmetic because it's adding 2 each time. So the sum is going to be 60 rows divided by 2, 20 plus the last row. How many chairs are in the last row? Well, we have to set up an explicit formula and plug in n equals 60 to find out how many chairs are in the last row. So our explicit formula would be a sub n equals 18 plus 2n. Or the other one, a sub n equals 20 plus 2 times n minus 1. And then we're going to plug in n equals 60. I want to find the 60th row, how many chairs there are. How much? 138. Perfect. So I get 138. I go back up to here and plug in 138. Don't forget at the end to multiply this one by 2. I don't know if I'm going to put such a tricky one on there. It might just have one section. But there's 4,740 seats in that one section, and there's 2 of those. So there's 9,480 total seats. All right, last one. I think we're going to finish. The first term of a geometric series is 8. If there are 20 terms and r equals 2, what is the sum? Okay, first term is 8, 20 terms. We can just plug everything in, right? Yeah. So the sum of these 20 terms is equal to a sub 1, which is 8, 1 minus 2 to the 20th power over 1 minus 2. It told me it's geometric. I'm going to use the geometric sum formula. 8 times 1 minus 2 to the 20th power. Oops. Did you get it already? Are you faster than me? Divided by 1 minus 2, or negative 2. Negative 1, I mean. All right, what'd you get? I got a big number. Did you get 8,388,600? 8 million? Oh, my salary this year. Oh, sweet. The year I was born and my salary. Wow, all in one worksheet. It's really good. Okay, so, yeah, so let's go back to number 13. And you would get, if you did that, 45,150.